Welcome to the video about implementing data architecture. After watching this video, you will be able to explain the Enterprise Data Architecture, or ADA principles to implement data architecture, describe the technologies and process of implementing data architecture, and list the benefits of data architecture implementation. As you know, capital markets banks operate in a high-stakes environment characterized by the need for rapid decision-making, regulatory compliance, and data-driven insights. Implementing a robust data architecture aligned with Enterprise Data Architecture, or EDA principles, ensures seamless data integration, efficient processing, and scalability. Let's look at the practical implementation of such architecture, focusing on principles, techniques, and tools tailored to the banking industry. ADA is the foundation for managing data effectively across an organization. To begin with, you must understand the principles that will guide you to implement ADA in a capital markets bank. Data integration and interoperability ensure seamless data flow between departments such as trading, risk management, compliance, and operations. It also enables interoperability between legacy systems, modern platforms, and external data sources. Scalability and performance are crucial in designing the architecture to handle the growing complexity and volume of high-frequency trading and analytics. Data governance and security help enforce robust data governance policies for accuracy, compliance, and quality. This principle is the key to implementing strong security measures to protect sensitive trading and client data. Real-time processing facilitates real-time data ingestion and analytics to support decision-making and trading operations. And creating a modular architecture for flexibility allows the integration of new technologies and tools without disrupting operation. Implementing data architecture involves techniques such as data modeling, data integration, data storage, real-time analytics, data governance, and security measures. Data modeling involves developing a conceptual, logical, and physical data model using tools like Irwin Data Modeler or IBM Infosphere Data Architect. With data integration, you connect disparate systems using API gateways and middleware platforms such as MuleSoft and Apache Camel. For data storage, you can take a hybrid approach. You can use data lakes to store raw market and trading data with Amazon S3 and data warehouses to store structured, aggregated data with Snowflake. Real-time analytics help you implement real-time data streaming using Apache Kafka and process real-time analytics with popular frameworks like Apache Flink or Spark streaming to support trading and risk analysis. For data governance, you can use platforms like Calibra or Elation to manage data lineage, cataloging, and compliance, and define policies for data access and usage to ensure compliance with regulations. As security measures, you can deploy encryption protocols such as AES-256 for data at rest and in transit, and use systems like Splunk or IBM QRadar for real-time monitoring. The data architecture implementation process consists of 5 phases. The first phase is discovery and planning. During this phase, you audit existing data systems and workflows and define the architecture's objectives, aligning them with the bank's business goals and regulatory requirements. The next is the design phase, where you develop architecture blueprints, including data flows, integration points, and technology stack diagrams. You also design the data governance framework to address compliance needs. The third is the deployment phase, where you set up the cloud infrastructure and storage layers. Then, you build and test ETL or ELT pipelines for batch and real-time data ingestion. Finally, you will deploy middleware solutions for data integration across systems to conclude this phase. Phase 4 involves enabling analytics by integrating business intelligence or BI tools for reporting and visualization. Then you implement machine learning models for predictive analytics and risk management. The last phase is the monitoring and optimization phase. Monitoring tools like Grafana and Datadog allow you to track system performance and troubleshoot bottlenecks. As business needs keep changing, you must continuously optimize data pipelines and storage solutions. Implementing data architecture offers lots of benefits. Firstly, it gives you a unified data view by consolidating data across departments, which breaks down operational silos. It also enhances decision-making as real-time analytics empower traders and risk managers with actionable insights. Automatic regulatory compliance reporting reduces manual effort and errors. It also supports the growing complexity of capital market operations with modular, scalable, and agile systems. It also enhances customer experience by enabling personalized services through a 360-degree client data view. In this video, you learned that EDA is the foundation for managing data effectively across an organization. Principles that will guide you to implement EDA in a capital markets bank include data integration and interoperability, scalability and performance, data governance and security, real-time processing, and modularity. The data architecture implementation process consists of 5 phases: the discovery and planning phase, the design phase, the deployment phase, the analytics enablement phase, and the monitoring and optimization phase. Implementing data architecture can provide benefits such as a unified data view, enhanced decision-making, regulatory compliance, scalability and agility, and customer experience.